Imagine getting this linked list in an interview. 1, 1, 2, 3, 3. And the interviewer asks, how would you remove duplicates without using extra memory? Most people panic because this isn't an array. This is a linked list. But today, you'll learn the exact interview pattern behind this problem. And by the end of this video, you'll solve LeetCode 83 like a pro. But today, we'll cover intuition, brute force, optimal solution, dry run, time complexity, and hidden tricks interviewers expect. Let's begin. We are given the head of a sorted linked list, and we need to remove duplicates. So every element appears only once. But here's the keyword that changes everything. Sorted. Because the list is sorted, duplicates will always be adjacent. This single observation gives us the optimal solution. Before coding, always pause and think. If duplicates are next to each other, do we really need nested loops? No. We only need to compare current node and next node. If both are same, duplicate found. Otherwise, move forward. That's the entire pattern. Now let's first build the brute force solution. The idea is simple. Traverse the linked list. Store unique values in another data structure. And create a brand new linked list. For every node, we check if the value already exists. If not, we store it. And this is where the problem starts. Because checking inside a list takes time. So overall, this becomes O, and superscript 2. Let's look at the code structure. We define the class and function. We initialize an empty list and set current to head. We traverse the linked list. We check if the value exists in our list. If not in, we store it. Then we move current forward, skipping duplicates as we go. Now we build the new linked list, iterating through unique values, creating new nodes one by one, until the list is clean. Time complexity is O, and superscript 2. Space complexity is O, n. Works. But definitely not optimal. Now let's use the most important property again. The linked list is sorted, so duplicates are adjacent. And that means we can solve this in one traversal. We use one pointer called current. Then compare current node with next node. If values are same, we skip the duplicate node. This is the magic line. We are literally removing the duplicate node from the chain. No extra memory. No new linked list. Pure in-place optimization. Now let's write the final optimized solution. We define the class and function. We initialize current to head. Traverse while current and current.next exist. Check if current value equals next value. If they match, skip the next node. Otherwise, move forward. Finally, return the head. That's it. Simple. Efficient. And interview ready. One traversal only. O of n time. And O of 1 extra space. This is the best possible solution. Here are some interview tricks. When you see sorted array or sorted linked list, always think about adjacent comparison. Never move current immediately after deletion, because duplicates may still exist. 1, 1, 1, 1. Always check current.next before accessing it. Otherwise your program crashes. And that's how we solve LeetCode 83, remove duplicates from sorted list. Today we learned brute force approach, optimal approach, linked list pointer manipulation, complexity analysis, and interview tricks. If this video helped you, please like and subscribe. And remember, the best coders don't memorize solutions. They understand patterns. I'll see you in the next one.